In this example, we are supposed to find the capacitance of a parallel plate capacitor, the charge on each plate, and then the electric field between the plates. So for this, we're going to need to know a couple equations. Let's start with A, where it asks us to find the capacitance. Remember, capacitance is dependent on the geometry and the materials of the capacitor. So that's K E naught times A over D is equal to the capacitance, where A is the area of the plate, D is the distance between the plates. Now, K is actually the dielectric constant. If we don't have a dielectric constant, then we can just let K be 1. If it's air, K is 1. So we'll start with that. So let's go ahead and find the area. So the area is, the plates are 20 by 3 centimeters, so I have 0.2 meters times 0.03 meters, which is 0.006 square meters. Do note that this constant, the permittivity of free space, does have units of Coulomb squared per Newton meter squared, so we do need to make sure we are in base units. And then it says the difference, the distance between those is 1 millimeter. That's 0.001. So there's A, here's D, 0.001. And so then all we have to do, this is an air gap, so this is K is 1. All we have to do to find the capacitance is say C is equal to 8.85 times 10 to the negative 12th times 0.006 over 0.001. 5.31 times 10 to the negative 11th. Now, that's a fairly small number. We're actually going to report it as picofarads. So this is 53.1 picofarads. Pico, and that's a capital F, pico is times 10 to the negative 12th. Right? So nano is times 10 to the negative 9th. Pico is times 10 to the negative 12th. There's a smaller one, femto, times 10 to the negative 15th. And picofarads are fairly common for the capacitance of capacitors. We will deal with some in lab that are quite a bit bigger than that. B says to find the charge on each plate. So to find the charge on each plate, remember Q is equal to the capacitance times the voltage. Well, it says when it's hooked to a 12-volt source. So to find charge, Q equals our capacitance, we just found, 53.1 times 10 to the negative 12th, times the voltage, 12, which is going to get us about 66.4 times 10 to the negative 10th coulombs. Then C says, what is the electric field between the plates? This is a throwback question. Remember, electric field, one way to calculate electric field is to take the voltage divided by the distance. And so if we know the voltage is 12 and we know the distance is 0.001, then the electric field strength between these two plates is 1.2 times 10 to the 4th volts per meter. It's also newtons per coulomb, but volts per meter will work. And then question D says, what happens to all of these things, Q, C, and V, if a dielectric with K equals 4 is put between the plates? Now, what you have to remember is this capacitor is actually hooked up to a battery. If it was a capacitor in isolation, then the voltage would actually decrease when we put a dielectric in there, because it would create a field that opposes the field between the plates. But because it's hooked to a battery, this 12 volts will maintain a 12 volt potential. So the first thing I can say is, well, the voltage does not change. V is constant because it's hooked to that battery. That means Q and C are going to change. I know the capacitance is going to change because I just increased it. I increased it by quite a bit. I put a K of 4 in there. So what happens is my capacitance goes up by a factor of 4. And so my capacitance is no longer 53 picofarads. It's whatever 53 times 4 is. 53 times 4 is 212 picofarads. So my capacitance C becomes 4 times E naught, or permittivity of free space, E naught, A over D. I don't have to do all that math again. I can just multiply by 4. And like I said, that's 212 picofarads. It's a capital F. And then it says, well, okay, then what happens to the charge on the plates? Well, Q is still C times V, since the voltage didn't change, but this went up by a factor of 4. This also has to go up by a factor of 4. So I get 2.5 or 25.6 times 10 to the negative 10th coulombs of charge. So what happens when we put the dielectric between these plates is it actually allows more current to flow. So very temporarily what happens is the potential difference between those plates will go down, and that allows the current to flow until we've reached that same potential difference again. And then we will have more charge stored between those plates because we've increased the capacitance of the capacitor.